Muted.
Good morning, everyone. It's Jonathan Hamilton from Point Alliance. All right, so it's 11:30, so we're going to get started. Thank you for joining us this morning. We are very excited to present our latest installment of our Solutions for Success webinar today on the mobile cross-platform development with Xamarin. We have Fetbi Irsat, who will be leading this session, one of our lead architects, both a Microsoft certified developer as well as a Xamarin certified developer. And if you don't know already, those things are tightly linked together. And Fetbi is going to walk you through the great benefits of leveraging the Xamarin platform, and why, especially if you're a C# developer or a C# and Microsoft development shop, this is a great consideration for you when looking to develop and deploy mobile applications. So without further ado, I will turn things over to Fetbi.
All right. Hi, everybody. My name is Fetbi. As Jonathan said, I'm one of the lead architects here at Point Alliance. And today I will be talking about Xamarin, native application development for iOS, Android, and Windows Phone. Let me just start showing my screen. Hopefully everybody can see it. All right. So what is Xamarin? Xamarin is a cross-platform application toolkit that where you target iOS, Android, and Windows Phone using C# and with high degree of code sharing. Before we get into Xamarin, I'd like to talk about the history of Xamarin because it has an unusual history. In the year 2000, Microsoft introduced the .NET framework, and a young developer named Miguel de Gaza said, well, why can't we run the .NET framework on different platforms like Linux or a Mac? So he started an open source project to implement the .NET framework on a Linux. It was very ambitious. So shortly after, Attachmate bought Novell. And really shortly after that, Xamarin was born, where Novell granted Xamarin the mono license. And today, Xamarin has over 1 million developers in more than 120 countries around the world. All right. So next, I'd like to talk about the products that they offer. So the first thing that they offer is the Xamarin platform, and that's what we'll be concentrating on. And basically, it offers you the C# language and ability, anything that you can do in Objective-C, Swift, or Java, you can do in C# for iOS, Android, and Windows Phone. The next thing that they offer is the Xamarin Test Cloud. And basically, what that is they have a whole bunch of hardware of different screen sizes, different hardware, different RAM, different ROMs, different everything, all the hardware out there. There's like hundreds of them. And what they do is you can create your own test scripts, upload it to the test cloud, and then it gets tested on hundreds of different devices. Usually when you're developing, you have a small subset of devices that you can test on, but the average consumer may not have your device. So this test cloud that they offer is actually really, really good. You can take screenshots, you can take stack traces to see where the error occurred. For example, if the device has low memory and your application is using a lot of memory, you know that on that device it doesn't work and you can do some workarounds. They also offer something called Xamarin Insights. And what that does is it's a library that you incorporate into your application. And every time there is an error, it gets uploaded. That error gets uploaded to the cloud, and then you can have a look and try to fix that error in the next update. They also offer the Xamarin University, which I've attended and graduated from. And basically, it's a bunch of live online courses by real instructors. And they have over 50+ classes that you ask questions. They offer offline learning, office hours. It's really great. All right, so next thing. Now, why would you use Xamarin? If you're using Xamarin, the benefits are really about code sharing, C#, and easier to develop. So when you're using Xamarin, you're sharing about 60 or 75% on average of your code between iOS, Android, and Windows Phone. You're also leveraging you might, if you have C# experience in-house, you would leverage that knowledge to build mobile applications. And it's easier to learn because if you have C# in-house experience, it's so much easier to learn mobile than if you went to platform-specific tools like Java and Eclipse, Objective-C, and Xcode for iOS. So you need, if you were to do platform-specific, you need a different set of skills for Android, a different set of skills for iOS, and a different set of skills for Windows Phone, for example. You can't absolutely share any code between them, and because they're so totally different. And also increase code maintenance costs. So if you need to make a business logic change, you would need to implement that in each platform. Whereas in Xamarin, you would implement it just once, and it would run on all 3 platforms. So that's awesome. So there are 2 fundamental ways of creating mobile apps in Xamarin. One way is where you're writing your UI layer specifically for each platform. So one UI, you build your UI in Android, you build your UI in iOS, and you build a different UI for Windows Phone, for example. And then your business logic is shared between all the 3 platforms. So the first, what we'll look at is Xamarin Android. So this is their Android implementation for C#. So basically, anything that you can do in Android Java with Eclipse, you can do with Xamarin Android. And also in Xamarin, you get the benefits of code sharing. So my business, and we'll look at that in just a second. And also you can use Visual Studio or their own IDE, which is called Xamarin Studio. iOS, so this is their iOS implementation. And everything that you can do in Objective-C and Swift in Xcode for iOS, you can do with Xamarin iOS in C#. And again, there's an average of 75% code sharing because you're sharing your business layer, your models, your database access layer, your service layer, everything's shared. You just write it once and it's shared between Android, iOS. And one note, when you're developing for iOS, you absolutely need a Mac. You have to have a Mac because it gets compiled on a Mac using Xcode's compiler. And if you're doing Windows Phone applications, you would need Visual Studio with Windows 8. So you may already have that. And you don't need Xamarin. So this is how the architecture is. On the left, we have our code sharing block, or shared code block, where you have, I don't know if you can see my mouse. Yes, you can. Your data layer, where you have your local database storage. So that would be your SQLite. That's usually what's used. And then you have your data access layer, where you're pushing and pulling from the database. Then you have your service access layer, where you're pulling and pushing from your RESTful API, for example. So that's all of that is shared. And then you have your business layer, where you're making business decisions, business logic. Again, that's all written in C#, and it's shared between iOS, Android, and Windows Phone, including your models. So all your objects and models are shared between the three platforms. So this is one way of doing it. Your iOS app now has to have its own UI layer, where you have complete control on how the UI is presented. You also have your application layer, which uses the Xamarin iOS SDK assemblies. And same for Android, same for Windows Phone. So all three have to have their own UI implemented in their own way. And on the right, you would have an example solution in Visual Studio, where we have our portable library, which is where all your business logic is. Our Android project, that's where your Android UI is. And then the iOS project, where your iOS UI is set. And they all use the shared code, which is our portable class library. The second way of doing applications in Xamarin is something called Xamarin Forms, and that allows you to create cross-platform UIs. So you write your UI once, and it gets translated into each platform. So for example, I create my button or my input field or my list in Xamarin Forms, and then it gets translated to iOS. So in iOS, it would be a UI button, UI data table, and it gets in Android, it would be a button view, UI list or list view, etc. And then again, your application logic sits in one place. So you define your UI in one place, you define your business logic in one place. And this allows about 100% code sharing. So you write once, and it runs on all three platforms fairly easily. And you can make minor tweaks here and there. And this is actually a really good representation of how much code you would write. So if you look at the native iOS app, for example, this little bar represents how much code you would write in Xamarin Forms. So it's very little compared to the rest. So the shared C# interface code, which is your UI layer, is written once. Your shared application logic is written once, and very little code in any one of the platforms. Now, your code is actually compiled into, it's not interpreted. It's C# code that gets compiled differently for each platform, I just wanted to make a note of that because each platform has its own way of doing things. So in iOS, your C# code is compiled ahead of time, which is what Apple requires. It gets compiled into our ARM assembly and gets run on your iOS device. The Android and the Windows phone get compiled into IL, and then they do just-in-time compiling when the application starts, just like any other application on those devices, platforms. Now you might be wondering which platform is right for me. When you're starting a new project or a new mobile application, there are things that you need to consider. So if you want to use Xamarin Forms, it's best for data entry apps because out of the box, the UI controls are fairly simple. What they've done is they've taken all the common properties of each control. So for example, a button may have the background property in all three platforms, and it's supported in Xamarin Forms, but it doesn't have something new that was introduced in Lollipop, for example, like they introduced a new property called raising or adding a shadow to the back of the button to give it that material design, as they call it. You don't have access to it out of the box for any one of the Xamarin Form controls, but what you can do is you can extend the existing buttons and implement your own. That's why it is a simple UI, but you can extend it for each platform. Prototype and proof of concept because it's fast to develop, and also apps where code sharing is more important than custom UI. Again, you can overwrite for each platform. It's just you need to do it. It doesn't come out of the box. For Xamarin iOS and Android, so this is apps that require specialized interactions like push notifications, Google Play services, iOS HealthKit as another example. These are just examples. You can actually gain access to these from Xamarin Forms, but you need to implement them again. It doesn't come out of the box. It's where if you need highly polished design and platform-specific APIs, and where custom UI is more important than code sharing. All right. So we have a demo that we want to show you. It's an app that we've built using Xamarin Forms, and what it does is I don't want to say track it. You can see statuses of your employees or other colleagues. And the structure of the architecture is fairly simple. So we have a web API using REST to return and accept JSON. We have our SQL server, and we have our mobile application that accesses everything through REST. All right, so let me go into Visual Studio. So I'm using Visual Studio 2015, and you can use Visual Studio 2013 and 12, I believe, for Xamarin. And I already have Xamarin installed and working as needed. So let's have a look at our solution. So in my solution, I have 3 projects. One is Wave Portable. That's where all my business logic is. That's where all my screen UIs are, and actually most of my code, or close to, I would say 98%. of my code is in here. And then I have my Android project. So when I compile this project, it creates an Android application for me to run. And I also have my iOS project. So when I run this project, it creates an iOS application.
There's just one question.
Sure.
For us.
Okay, one sec. You don't see it. I don't see it.
Well, the question is that how about the security? Can I use it for banking system, and what type of security I can implement here?
You would have the exact same security as a native application. So if you had RESTful APIs or WCF, you can access them the same way you would access a normal .NET application. So when you're accessing your REST or WCF, you're using HTTP client to access them the same way. And you would use SSL, put your tokens or whatever in the header, and the same way. There's no difference. I hope that answers your question.
Thank you.
I'm going to quickly go through some of these. So in my project, it's a portable library, which means it's a subset of .NET, and you would it's fairly common now to see portable libraries used in web applications, WPF, and so on. So the same is true here. So I can use my portable library, and right now it's targeting. Oh, I need to stop it first. All right, so I'm targeting Xamarin iOS, Android, Silverlight, Windows 8, and .NET 4.5. I have some of my contracts, which are interfaces, and because the portable library doesn't know how to calculate MD5, so I'm creating an interface that is implemented in my Android and my iOS. Also, portable libraries don't know about local file systems. So again, I have interfaces that load and save or cache some of the data that I'm getting. So this one I'm not using just yet. This is to load assets within my mobile application, so that Android, for example, has native asset support where you can embed your own fonts, you can embed your own text templates to display. So this loads that. But I'm not using it just yet. I'm using it I will use it in future phases. Actually, let's look at the application first before I dive into the code. I'm going to run this in my emulator. So that's the splash screen. And we're now at the login. So the way the login page works is I get the login password. I pass it to my web API using REST. I just do an HTTP post. From there, I get back a token, and I keep that token very secret in my application. And every request that I make, I use that token. So I'll just log in right now. I'll just quickly show you the sign-up screen too. So that's the sign-up screen where you can first name, email, password. And this works the same way. All right. So let's log in. Hopefully I have network connectivity. Yes, good. So once you log in, what we do is we get a list of all the users that are associated with my organization. And you see a bunch of profile pictures, and we're using a service called Gravatar to get their images. So it looks like some people do not have a profile associated with them, and then we display a default picture. And also I see their statuses, and it looks like Ruby is out to lunch, and I'm in the office, and so on. So now I can click on who should I click on? John Zeri. So when I click on John Zeri, I can see his status and about 10 of his past history of where he was. Let's go back. I can also refresh by pulling, and this is it is defined in Xamarin Forms, but it's full material design, so it's using the latest Android material design implementation that Android or Google released. So we're not doing anything tricky here. We're just using whatever the Google SDK or the Android SDK to display material design. So let's add a status. So I'm going to tap on the plus icon on the top right corner. And what this will do is load up a new screen with my own profile, and it gives me a bunch of predefined options of where I am. So I'm going to choose, I'm in a meeting, and as soon as I do that, it pushes that to the server, to our API, and then updates my status. So there you go, in a meeting 7 seconds ago. And anybody who logs in will be able to see my status. We also have push notifications working, so if you change your status, other people will get push notifications. We also have a side menu where it's your home page, your me, which is your own profile, contact us, and Point Alliance. Just go to a browser. So open up the default browser, and you can log out. So there it is. It's a fairly simple app. It was actually fairly easy to do. So let's go back to the code. So as I said, everything, all the screens, all the pages are defined in my portable class, and they're defined only once. And I didn't have to define one UI for Android, one UI for iOS, so I didn't have to do that. So if we look at, we can look at the models. They're all in C#. Everything's in C# or XML, and I'll show you the XML in just a second. So here's my model. Here's my action model where I've given it a JSON property. So I've done it for all of them, and the reason I do this is, so for example, the name is actually N when the JSON is constructed, and that's to reduce the amount of network traffic that goes between you and the server. So if you're on the train, for example, on the GO train or on the TTC bus, there's less traffic going through your data connection than if you're on the Wi-Fi. So if we look at our screen, and we'll look at let's look at the login page, for example. So this is my screen for the login, where I've defined an image, so a label, and a bunch of entry fields for my login and password, and a bunch of buttons to do the sign up and the login. So if we go back to my emulator, let's just log out. So this image right here is this image. My entry fields, login, password, and there's the corresponding fields. So once I define this one UI, it gets translated into iOS, it gets translated to Android, it gets translated to Windows Phone using native controls. It doesn't create its own controls. It actually uses the existing native controls that already exist in that platform, which is great. We can look at some of the other pages, like the home page, for example. Home page is fairly simple. So I have my list view defined, and then I have my template. Again, this is using XAML. It's not the exact, if you've done WPF applications, it's not the exact same XAML, but it's fairly close. And I'm using bindings to bind my data to the data, to my model. Here's my binding. It's fairly close to the WPF XAML implementation. And if we look at the code behind, if you've done any type of WPF or web applications, this will look very similar. So here's my event. I'm assigning events. When I click on login, it calls this event. And when I click on sign up, it calls this event. So I'd like to show you something fairly cool. I'm going to run my iOS application in Visual Studio, and what it does is it creates a bridge between your Visual Studio and your Mac computer that has Xamarin installed. So I have my MacBook Air with me. So it creates that bridge, and you can also do remote debugging. So I'll quickly demonstrate that. So stop this. I'm going to set my iOS as the startup project. Let's see if this will work. I'm going to connect to my MacBook Air. All right. Let's see if it will. Oh boy. See, forget this Mac. Like it's doing something. It's connected. All right. Great. So now I can see that it's connected, and now I have the profiles of what's available on that Mac. So we're going to launch it on iPhone 6, and we'll change the presenter to the Mac soon, fairly soon. But I want to show you something before. So I'm going to launch it in iPhone 6, and so what this will do is it'll launch the emulator on my Mac, and then I'm going to try to log in and click on the login, and what it will happen is this breakpoint will hit when I click on login on my Mac, which is awesome. Okay, it's just the emulator is loading right now, and the application should just load. So what this did is it packaged up the entire application, sent it to the Mac, compiled it on the Mac, and then launched the emulator. All right. So now on the Mac, I'm on the login page. I'm just going to type in my password, login and password. And now I'm clicking on the login button. what should happen now is, oh, it didn't work. Oh. Okay, let me do that again. It's done this every time. Like it's worked every time, except now. Of course, live demos, right? All right, so it's recompiling. Come on. Did my Visual Studio crash? All right. Wow. I must have done this like hundreds of times. And of course, when I'm demoing it, it didn't. Okay, let's move over to the Mac. All right. Give me 1 second. And I'm going to go entire screen share. All right. Great. Let's hide that. So on a Mac, what happens is there is no Visual Studio. Visual Studio only runs on Windows. And so what Xamarin has done is they created their own IDE, and it's called Xamarin Studio. I'm just loading that up now. So I have the exact same application on the Mac. Great. And then I'll load it up in the emulator. So this emulator is the emulator that comes with Xcode once you install Xcode. And it's the exact same application, like same UI logic. I didn't change anything from Android.
We just have one question. Can I use a Mac VM to do the same, or I have to have a real Mac?
You can use a Mac VM. I know there are. I've played around with a Mac on VMware. It's fairly slow, and I don't recommend it. You can do it. It's just fairly slow, and you'll have a lot of trouble. It's better to just get a Mac or buy a Mac Mini. That's the easiest or cheapest solution. If you have a really fast one, then that'll work. So let me just log in. So again, it's the same UI. As you can see, some of the UI is different. On a Mac, the button doesn't have any borders by default. We can add them, but I just wanted to show you that it is different than Android, even though it's the same code that's running on here. So even the progress indicator is different. Oh, did I start wrong? Point. Do I have internet? Yes. Interesting. Must have typed it in wrong. Okay, so I have the exact same list view. Everything is exactly the same. And also using the iOS way of presenting data. So for example, if I had the tab control, the tabs on Android would appear at the top, and then on iOS the tabs would appear at the bottom. So it's using the native controls that come with each platform. Just want to make that very clear. Again, same UI. And side menu. And as you can see, the side menu is slightly different than on Android. It pushes the screen to the side, which is the default behavior in iOS, whereas in Android, the screen stayed on the left. Sorry. That's it for the demo. So we can. And of course, we have access to Nuget packages. So I'm using Nuget. Nuget is like first-class citizen on Xamarin, both Xamarin Studio and Visual Studio. So right here, I'm using the Microsoft VCL Nuget packages, my HTTP clients, the Newtonsoft JSON that most web applications install, and some Nuget packages that are specific to Xamarin. So this XAM plugin connectivity gives me access to, tells me if your mobile device is connected to data or Wi-Fi. And also push notification, it makes it easier to do push notifications in Xamarin Forms. This Nuget package gives me access to creating a circular image, so the one you saw in the profile images, and settings, and the actual Xamarin Forms is a Nuget package. And also Xamarin Insights, that is the crash reporting and analytics. So if we look at the Android, you can see that there's very little code that you define that is platform specific. So it's basically initializing third-party controls that I'm using, and then loading up the Xamarin application or the framework that takes over the entire screen of the mobile device. And that's it. That's all I've written that is platform specific. Everything else is done in one code base. And the same for the iOS. Let's look at I have delegate. If you know iOS development, this will seem so familiar to you. So we have same terminology, but using C#. So again, I'm doing initialization, and then loading up my application. That's Xamarin Forms.
We have one more question.
Sure.
How is the performance of the app developed by Xamarin compared to the native apps?
Right. So because this is using Mono, it's just like implementing it's just like running a .NET framework on a Windows device, for example. So it needs to load up Mono when the application starts. So there's like on Android and iOS, there's I would say 200 to 300 millisecond delay on when the application starts, then compared to a Java or Objective-C. Other than that, I haven't really seen much difference. It's just that first load of the Mono framework into the memory. Other than that, I haven't seen much difference. And in some cases, there are the garbage collector that comes with Mono was much better than Android, maybe 7-8 months ago, and Android has improved that. So it's now on par with .NET or the Mono framework that comes with Xamarin. There's also on Xamarin Forms, if you do complex list views, So for example, we go back to way application. Okay, so this is considered semi-complex because I have one image, two images, a label, and a label. So 3 labels and 2 images. So if you run this on an Android device, I've noticed that if you do very complex list views in Xamarin Forms, it's actually fairly slow. So what we've done to combat that is implemented the layout in Xamarin Android, and that gave us the performance boost that we needed. If you were to do this exact same list view in Android, Xamarin Android, there's no difference between Java. It's just Xamarin says in Forms it's very complex to do list view in Android, so it's a bit slow if you're doing complex list views. That's the only thing I found actually.
Okay, well, I think if there aren't any more questions, again, we thank you for your time, for sitting through our presentation on the Xamarin platform. Hopefully, it's been insightful and helpful to you. We, again, would be more than happy to chat with anyone in more detail who's looking to either, A, develop their own mobile application on the Xamarin platform and is looking for some guidance and best practices, or B, if you're looking for some assistance in developing that first application. Again, we'd be more than happy with chatting with you about that. So thank you very much for your time. We will be running another Solutions for Success webinar in 1 month's time on website CMSs, I believe. So if anybody is interested in that, we encourage you to join us for that and check out our website for other upcoming webinars. So thank you very much for your time and have a great afternoon.